All right, we're going to move on to something called systems of equations. And there's three different ways to solve a system. And the first is by graphing. So what is a system? It's just a set of equations that are dealt with together. So when we talk about a solution to a system, we're talking about an ordered pair. So the place where x and y, where the x value and the y value are going to be the same for both equations. So looking at the first example, where are x and y the same in the two purple graphs? It's when they intersect right here. Okay, so our solution is this ordered pair x comma y. Okay, we can also have a situation where the lines, notice the lines here are parallel. So will they ever intersect? No. Okay, so this is no solution. There's no ordered pair that satisfies both equations. And this happens when the lines are parallel, which means that the slopes are the same. But we have different y-intercepts, or b values. Okay. The next one, this is actually a system where we have two lines, one on top of each other. So every ordered pair is the same. So this is infinite solutions. And this is when the lines are the same. Okay. And that means that the slopes and y-intercepts are equal. Okay. So three different situations we can have. We'll have an ordered pair as a solution. The system could have no solutions, or it can have infinite solutions. Okay. So here we're going to graph the systems. We're going to graph the systems, identify the solutions, and verify the solution algebraically. So number one, first we're going to start by graphing. So I'm going to look at my first equation and be like, my slope, or the m value, is -1/2 right here in front of the multiplier in front of x. And then the b value is the constant, which is 1. Okay. Next up is the second equation, which I can see the slope is 1/3, and the b value is equal to 6, the constant. All right, let's start with the second, since I'm already in purple pen. I'm going to go up to 0, 6, so 1, 2, 3, 4, 5, 6. Go ahead and graph my dot. And the slope says from there, I earn $1 every 3 days, or 1/3. I'm going to go down over 3. More dots is better in this case. And then I'm going to go ahead and graph in this line. Okay. And I'm a little bit off. I'm going to try again. Try and use a ruler, please. Okay. Next up, the second value, the top line, I'm going to graph my b value of 1, and then I'm going to go down 1 to the right 2. Because it's negative, we want to make sure our line is negative sloping. Down 1 to the right 2, down 1 to the right 2, or up 1 to the left 2, up 1 to the left 2, up 1 to the left 2. And I can see where this intersects, but I'm going to go ahead and draw in my line. All right, so where is the point of intersection? The point of intersection is at -6, -6, 4. So the solution is -6, 4, or we call this the point of intersection. It's where the x and the y value are the same for both equations. Okay, so we've done part 1. Part 2 is identifying the solution, and now we're going to test our solution algebraically. So I'm going to take the green equation, y is equal to -1/2 x plus 1, and I'm going to substitute -6 for x and 4 for y. So the y becomes 4, and then -1/2 times 6 plus 1. I need to multiply first, so half of 6 is 3, and it's negative, plus 1. So I get negative, it's a -6 that I need to plug in. So a negative times a negative is a positive. So 3 plus 1 is 4. So 4 equals 4, so that verifies. Okay. For the second equation, y is equal to 1/3. Y is equal to 1/3 x plus 6. So again, we need to substitute the same value for y. So that would be 4 is equal to 1/3. And my x is -6 plus 6. Multiply first, giving me -2 plus 6. 4 is equal to 4. Verified. Now, if these both don't work at the same time, then that ordered pair is not our solution. Okay? Or you evaluated funny. All right, let's do the next one. So my slope is equal to -2/1. Okay? And my b value is -3. For the second, my slope is 3/1, and the b is 7. So I'm going to go up 7 and then graph. Okay, I am out of room, so I'm going to go down 1, 2, 3, and to the left to make a negative divided by a negative. Okay, down 3, left 1, down 3, left 1, down 3, left 1, down 3, left 1. Oh, that's very off. Okay, purple. Start with my b value. So I'm going to go down 3. And then I'm going to go, it's a negative slope, so down and to the right. So down 2 to the right 1. Or I can go up 2 to the left 1. Up 2 to the left 1. 2 to the left 1. All right, I'm going to go ahead and graph in my line to the best of my ability. Where you look for the point of intersection, which I can see is right here at -2. Wow. Okay, at -2, 1. So my point of intersection or solution is -2, 1. So I'm going to test -2, 1 into the purple equation, the top equation first, -2x minus 3, and then into the green. I'll just write them, 3x plus 7. So we want to make sure that it's the ordered pair that makes both equations true at the same time. Okay, so my x is -2, my y is 1. I'm going to plug in 1 is equal to -2 times -2 minus 3. Multiply first, so 4 minus 3 is equal to 1. And I see 4 minus 3 is 1, so 1 is equal to 1. Check. All right. So when you show your work, make sure you show all the way down to this last step and then a check to verify. Okay. So 1 is equal to 3 times -2 plus 7. So I get 1 is equal to -6. So 3 times -2 is -6. Okay. And then I'm going to go ahead and do -6 plus 7 is 1. Verified. Love. Okay, so since these both verify, we know that the ordered pair is the solution to both of the equations at the same time. Okay. Last one. We get some different types of equations here. They are both still linear, but we're going to graph them a little different. So x is equal to 3. I'm going to go ahead and just write it over here so I don't forget for later. Okay, so x equals lines, are they horizontal or are they vertical? They are vertical. So I'm going to go to x is equal to 3. and go ahead and graph in my vertical line. And then for my second equation here, minus 2 is equal to 1 over 3 times x minus 6. I can see that this is written in point slope form. So I'm going to go ahead and look and be like the slope is 1 over 3, like y minus y1 is equal to m times x minus x1. And there's a point that we pass through, which is it's opposite of what's here, so 6, comma 2. So I'm going to go to 6 and 2 and graph my starting point. And from there, I can count my slope. I'm going to count down and to the left. So down and to the left, 1, 2, 3. Down, 1, 2, 3. Down, 1, 2, 3. And then I'm going to go ahead and graph this line in. All right, so my point of intersection here is at 3, comma 1. So my point of intersection, which I'm going to abbreviate as POI, okay, is 3, comma 1. So I'm going to test the point 3, comma 1 over here. And I have only an x to plug in, so I'm going to go ahead and plug that in for x. 3 is equal to 3. Verified. Woohoo! All right, next one. We get y is equal to 1. I'm going to change my color. Minus 2 is equal to 1/3. X is 3. 3 minus 6. So let's go ahead and simplify each side. So 1 minus 2 is negative 1. And then order of operations says I need to do my parentheses first. So I get negative 3. Then I can go ahead and multiply these. 1/3 of negative 3 is negative 1. So negative 1 is equal to negative 1. Verified. So our solution checks out 3, comma 1. So that's how we solve a system by graphing. Now the problem with solving systems by graphing by hand is that when the ordered pair is not a whole number, then it's really hard for us to see what the decimals are going to be. And that's what we're going to look at next week. Okay? Different ways to solve to get more precise answers. And that's it.